Chapter 3, Section 4, Proving Lines are Parallel. The corresponding angles converse postulate. Now, if you remember yesterday, we talked about the corresponding angles postulate. Now we're throwing converse in. Remember, the converse is going to flip the order in which my hypothesis and the conclusion occur. So the corresponding angles postulate said that if two lines were parallel, then the corresponding angles would be congruent. When we switch those, the converse postulate says if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. The main thing to remember is yesterday we were given that the lines were parallel, and because the lines were parallel, we knew relationships that happened with the angles. Today we're going to flip that. We're going to know relationship with the relationships that the angles have, or that certain angles are congruent, and we're going to use that to say that the two lines cut by a transversal are parallel. So it's kind of flipping what we were doing yesterday. The alternate interior angles converse theorem says that if two lines cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. The consecutive interior angles converse theorem says if two lines cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. The alternate exterior angles converse theorem says if two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. The first example says that we are given that line M is perpendicular to line P and line M is perpendicular to line Q. It asks us to prove that P is parallel to Q. Remember, always first begin with what you're given. So my givens are that line M is perpendicular to P and line M is perpendicular to Q. Now, generally, they are not going to leave you hanging. If you look at the picture, notice that 1 and 2 angles, 1 and angle 2, have been labeled. So we're going to use those, because they're given to us in our picture, to prove that P is parallel to Q. If you notice angle 1 and angle 2, how they've labeled them, those two angles are alternate interior angles. That is going to help us, because notice that if M is perpendicular to P, then angle 1 would have to measure 90 degrees, and if M is perpendicular to Q, then angle 2 would also have to be a right angle, or 90 degrees. Because we are given that they are perpendicular, I can go from perpendicular to perpendicular lines forming 4 right angles. So I can say that angle 1 is a right angle and angle 2 is a right angle, because if two lines are perpendicular, then they form 4 right angles. Now that I have that they are both right angles, I can say that they are congruent to each other. So I can say angle 1 is congruent to angle 2 because all right angles are congruent. That's another theorem that we've talked about earlier in this chapter. Now, if I have angle 1 and angle 2, which I've already decided are alternate interior angles, and they are congruent to each other, I can say that the two lines being cut by the transversal are parallel. So I can say that P is parallel to Q because of the alternate interior angles converse theorem. We use the converse when we know something about the angles to tell us that the lines are parallel. This next example, we are given that angle 5 is congruent to angle 6 and angle 6 is congruent to angle 4. We want to prove that line AD is parallel to line BC. Notice AD and BC are the two lines that are on the left and the right of this parallelogram, or what appears to be a parallelogram. Always start with what you are given. So I'm going to say angle 5 is congruent to angle 6, angle 6 is congruent to angle 4, because we were given is my reason. Now, if you look at angle 5 and angle 6, in relation to trying to prove that AD is parallel to BC. 5 and 6 do not have a relationship that's going to help us prove that these two lines are parallel. If you look at angle 6 and angle 4, because they are set congruent to each other. Those would be corresponding angles, but they're not for the right lines to say that they are parallel. We're trying to prove that AD is parallel to BC, which are on the left and the right. That would help us prove that the two lines AB and DC were parallel, but that's not what we're trying to prove. If you notice, there is something that I can do, though. You know that angle 5 is congruent to angle 6, and angle 6 is congruent to angle 4. If you look at angle 5 and angle 4, those two angles do have a relationship that could potentially help me prove that AD is parallel to BC, because they would be considered alternate interior angles of those two lines cut by the transversal. I can use the transitive property of congruence to say angle 5 is congruent to angle 4. Remember, when two angles are set congruent to the same angle, I can drop that same angle and set them congruent to each other. I just said that angle 5 and angle 4 are alternate interior angles. If angle 5 is congruent to angle 4, then I can say that AD is parallel to BC because of the alternate interior angles converse theorem. Converse is when we know something about the angles to tell us about the lines. The next example says, find the value of x that makes M parallel to N. For M to be parallel to N, the two angles that are measuring x plus 1 and 3x minus 5 have to be congruent. Why do they have to be congruent? What relationship do they have that makes it important that they are congruent for these two lines to be parallel? Well, if you notice, these two lines would be these two angles would be considered alternate interior angles. Alternate interior angles have to be congruent for the two lines to be parallel. So, to solve for x, to make M parallel to N, I can set them equal to each other. I need to combine like terms, so I'm going to subtract 2x from both sides to get me 1 equals x minus 5. Now I need to add 5 to both sides to get 6 equals x. When I plug in 6 for x, I'm going to get 13 on both, so I do have congruent angles, which would be making M parallel to N. The next example says, you notice when your windshield wipers on your car stopped, they each made a 30-degree angle with the bottom of the windshield. If the wipers were long enough, would they ever cross each other? Explain your answer. This is kind of hard to see without doing something. So, what do you think we can do? We could draw a picture of this scenario. If you notice, I have this line at the bottom, which would be considered the windshield, and then my two windshield wipers are coming out, each creating a 30-degree angle with the bottom of the windshield. Notice the transversal would be considered the line going across the bottom, or the bottom of your windshield, and you have the two lines, which would be your windshield wipers. These 30-degree angles are in corresponding places. Because the two corresponding angles are congruent, I can say that the windshield wipers are parallel. We know that they are parallel because corresponding angles, the 30-degree angles, are congruent. The next example says, is line AB parallel to line DC? Notice line AB is on the bottom and line DC is on the top of this picture. So we're looking at the bottom and the top lines. Notice this transversal that's cutting from point D to point B is creating 65-degree angles, and those would be considered alternate interior angles. Because alternate interior angles are congruent, I can say yes, alternate interior angles are congruent, so the lines are parallel. Now, B says is line BC, which is on the right, parallel to AD. If you notice ray BC and ray AD, try to find angles that have a special relationship with those lines. The 65, 65, and 40 degree angles don't really work here. They don't have a relationship with rays BC and ray AD. But if you notice, I have a 115 degree angle and a 155 degree angle in what should be corresponding positions. Because corresponding angles are not congruent, I can say no. Corresponding angles are not congruent, so the lines are not parallel. Today's assignment is on page 153, numbers 10 through 34 even, 37, 38, 44, 46, and 48.